Hey everybody. So this is going to be a bit of a review over the homework, and the assignment is 1.2 Segment Addition Postulate Practice. This was the first assignment posted a while back on Segment Addition Postulate. So I'm going to go through not all of them, but quite a few of these, basically until the bell rings, because I'm about to run out of time. So anyway, we're going to do probably the odds, and yeah, let's see how we do. So the idea is that these two smaller segments will add up to this larger segment. So we know that RS and ST will add up to RT, right? Which makes sense. This plus this equals this. And we can just solve it algebraically. So we're going to always start with the statement. So RS, actually, let's write on top of something because that'll make it easier for us. So RS plus ST equals RT. Right? RS plus ST equals RT. That makes sense. I'm just going to plug these in. So 4x minus 1 plus 5x plus 2 equals 19. Okay? Now we're going to start solving for x here because that's what we're going to do. We're going to solve for x. So we're going to combine like terms. So negative 1 and plus 2, that's going to equal positive 1. And then we have 4x and plus 5x. So 4x plus 5x is 9x. And now we're going to solve for x. We're going to get rid of our constants. So we're going to subtract 1 from both sides. 19 take away 1 is, of course, 18. So 9x equals 18. That doesn't look like a 9. And we're going to divide by our coefficient. So divide both sides by 9, and x should be equal to 2. Put it over here. Let's see if that works. So 2 times 4 is 8. 8 minus 1 is 7. So this is 7. That means this should equal 12 over here, right? Because 7 plus 12 is 19. 2 times 5 is 10, 10 plus 2 is 12. Yeah, it works. 7 plus 12 is 19. Look at that. Cool. Let's look at the next one. So let's go down to 3 here. Same idea. We're going to set up the exact same way. So we're going to put KL plus LM equals KM. And then 6 plus x minus 5 equals 2x minus 11. And we're going to solve this algebraically. So we're going to combine like terms. So 6 take away 5 is, of course, 1. So x plus 1 equals 2x minus 11. I'm going to get the x's on the same side here. I always like to move the variable with a smaller coefficient so it avoids having a negative coefficient, especially when you work with inequalities. I just find that is easier for me. But you could move either one. I just like to make it easier for myself. And then we're going to get rid of the negative 11 by adding 11 to both sides, and we're running out of room. And 11 plus 1 is, of course, 12. So x is equal to 12. All right, let's see if that works. 12 take away 5 is 7. 7 plus 6 is 13. Okay. 2 times 12 is 24. 24 minus 11 is 13. That works. Cool. Okay, let's go down to number 5. There we go. So AB plus BC equals AC. AB plus BC equals AC. So AB is 4x plus 2. BC is 8. And AC is 10x minus 2. So let's combine like terms here. So we're going to have 8 plus 2 is, of course, 10. So we're going to have 4x plus 10 equals 10x minus 2. We're going to subtract 4x from both sides. And that's going to give us 10 equals 6x minus 2. And I'm running out of room again. Add 2, add 2. I'm going to scroll over here. So that'll be 12 equals 6x. Divide both sides by 6. And x will be equal to 2. Let's check that again. So 2 times 4 is 8. 8 plus 2 is 10, so 18. And then 2 times 10 is 20. 20 take away 2 is 18. That works. Cool. Last one on this side. Okay. So we have IJ plus JK, just kidding, equals IK. Okay, so 5 plus 4x equals 6x minus 1. And then we're going to get the x's on the same side of the equation. So I'm going to move the 4x. So subtract 4x from both sides. That's going to give us 5 equals 2x minus 1. get rid of our constant, so I'm going to add 1 to both sides. It'll be 6 equals 2x. We're going to write it over here. 6 equals 2x. And then, that doesn't look like an x. And then we're going to divide by the coefficient, which is 2. So x will be equal to 3. And let's do a quick check again. So 3 times 4 is 12. 12 plus 5 is 17. 3 times 6 is 18, minus 1 is 17. That works. All right. So that's how you do the odds. The evens would be similar, but I just don't want to do all of them, obviously. But hopefully that helps explain any questions you might have. Let's go to the back side here. So find the full length indicated. So this is just going to require, let me try that in English this time. That's going to require us to find x first and then plug it back in to find the missing value. So it's just an added step, basically. So we're looking for hj, which is actually the entire thing. But we're still going to solve it the exact same way we did before. All right. Put it right here, actually, so we have more room. So hi plus ij equals hj. Okay. So 3 plus x plus 2 equals 2x minus 3. Because hi is 3 and x plus 2 is ij. So combine like terms, we're going to add 3 and 2 together. So we're going to get x plus 5 equals 2x minus 3. Now we're going to get x's on the same side, so we're going to subtract x from both sides. And we will have 5 is equal to x minus 3. And we're going to add 3 to both sides to get x by itself, and x will be equal to 8. However, we're not done, because now we need to use this to find hj. Well, hj is the entire length, so I can just plug it in right here, because that's hj. So 2x minus 3. That's going to become 2 times 8 minus 3. And use our order of operations here, so we're going to multiply first. So 2 times 8 is 16. And 16 take away 3 is 13. So hj is equal to 13. That's that. Okay, jk. So jk, we're going to set it up the exact same. So jk is a smaller segment, that's fine. So jk plus kl equals jl. So jk plus kl equals jl. jk is x minus 6, kl is 8, and jl is negative 10 plus 2x. Okay, we're going to combine like terms, so negative 6 plus 8 is going to be positive 2, so x plus 2 equals negative 10 plus 2x. That doesn't look like an x. Now it does. Let's get the x's on the same side, so we're going to subtract x from both sides. That's going to be 2 equals negative 10 plus x. Now we're going to add 10 to both sides. And 2 plus 10 is 12. So x is equal to 12. So jk is here, so we're going to plug in x here, so 12. So x minus 6, 12 minus 6, and 6. So jk is equal to 6. You can see that this is just really plugging it back in. All right, let's do the last two here. And I think I'll be able to finish before the bell rings. EF is going to be the segment here, so DE plus EF equals DF. So DE plus EF equals DF. DE is 2x minus 9. EF is x. And DF is 15. So combine like terms. We're going to combine the x and the 2x, and that'll give us 3x. Minus 9 equals 15. We're going to add that 9 to both sides because we use the inverse operation. So plus 9 plus 9. And that's going to give us 3x is equal to 24. We're going to divide by our coefficient, which is 3. And x will be equal to 8. Okay, so x is equal to 8. We're looking for EF. So guess what? EF is just x. So EF is 8. Makes our life easy. Okay, last one. Here we go. All right. Find GI. So GH, HI, GI. So we're going to find the whole thing here. So GH plus HI equals GI. So GH is 1, HI is x, and GI is 2x minus 5. Okay, so we're going to move the x over here because there are no like terms on the same side. So 1 will be equal to x minus 5, and then we're going to add 5 to both sides. And x will be equal to 6. Okay, now GI is the whole thing, so let's plug it in here. So 2x minus 5. And 2, we're going to plug in 6 for x. And 2, again, follow order of operations. So we're going to multiply here first. So 12 minus 5, and that's going to be 7. So GI will be equal to 7. And that's it. All right, so hopefully that was helpful. I know I went really quickly there, but hopefully that answers any questions you have. Did all the odds. Okay. And yeah, let me know how you did. If you have any questions, just let me know. All right, thanks, guys.